In today's lesson, we are going to be looking at different types of graphs and when to use them. So what we're going to be doing first is we're going to be looking at a bunch of different graphs, and there's going to be two of each type. So I'm going to scroll through them slowly, and if you need to pause the video, I do encourage you to do so. But what you're going to do is you're going to look at each graph and think about what type of data is best displayed in the following different types. So we're going to start off by looking at circle graphs. Again, take a look at what the data is showing. We can zoom in here a bit. If you need to pause the video to take a better look or to think about it a little bit longer, by all means go ahead. We're going to be moving on to bar graphs. And again, you're thinking about what data is best displayed in these following types. So we've moved on from circle graphs to bar graphs. So here we're looking at the revenue, mobile revenue generated by Minecraft worldwide. Revenue in million US dollars. So these are $81 million and so on. Moving on from bar graphs, we're going to be looking at double bar graphs. So this is looking at marks in math and science for students. Looking at another set, we're looking at the sales and the transaction price. So basically the price of the vehicle or price of vehicles as well as the sales or the number of sales that they've done. Looking at different motor vehicle brands. Moving on from double bar graphs, we're going to be looking at what we call histograms. So this is looking at the distribution of salaries of employees at ABC. So we see the salaries in thousands, as well as the number of employees in each category. We also have hours spent playing video games on weekends, so the number of students and the various numbers of hours. And then finally moving on to line graphs. So here we're looking at Amazon, where the price of Amazon, closing price, so looking at the stock price of Amazon over months. And here we're looking at temperatures in New York City over days in degrees Fahrenheit. So again, those were all of the graphs that we're going to be looking at. And again, I do recommend that you go back, pause the video on each graph, and take a second to really think about what type of data is being shown in these graphs, because that would give you an idea of what type of data is best used. So if you've taken your time to go through and look at that, let's go through and try to fill this out. So looking at the bar graphs. So if we go back to the bar graphs are best used to compare things between different groups. So if you go back and take a look, you'd see that we're comparing things between different groups. It can also be used to track changes over time if the changes are large. So if we have large changes, then it's okay to use a bar graph to show that. As well, bar graphs are good. So we have 1, 2, 3. Good for when the data is in categories. So if you go back and take a look at each one, you'll see that we do have categories of data, and we're looking at the different, it could be different values, but again, specifically, we're looking at categories. So if you go back and look, we're looking at large companies and looking at the revenue of each company. So again, the categories, looking at years for change over time, and again, looking at the values, but again, they are large changes, so that's why the bar graph tends to be relatively good. Moving on to a circle graph. So a circle graph is best used to easily show, actually let's color code it just to make it a little bit easier. To easily show the results in a proportional manner. So what this means by a proportional manner is that we're looking at the values compared as a part of the overall group or a population. So usually we're looking at percentages of a whole. Right, so we're looking to show percentages. And you can also think of it as it shows parts of something related to the whole. So that's when it's best to use circle graphs, when you're trying to show how the overall or the whole is broken down. Moving on to a double bar graph. So a double bar graph is best used to compare two kinds of information, situations, or events. Two kinds of situations, information, or events. So very similar to a bar graph, but we might have two situations or two events for what we're looking at. So for example, if you go back and look, we were looking at the marks for science and math for students. So the two situations were the two courses, math and science. We were looking at marks still for both of them, but we wanted to compare the two grades or the two courses. And so also the double bar graph displays two sets of related data. Moving on to our histogram. So the histogram is similar to a bar graph. So it does look very similar. So it is similar to a bar graph, except it has no spaces or no gaps. Sorry, not that it has no spaces between bars. And there is a reason for that. And the reason being is that the data is put into ranges or intervals. So they're not separate, they're just broken up into ranges. So the data is put into ranges or intervals. So this is usually when the data that we're looking at is numbers and not categories, because we may have differing values and we might not have all single values that we can just count how many of each individual one we have, because it might all be one. So we put it all into a range or into an interval. So again, usually the data is numbers, not categories. And you can go back and take a look at the two examples that we looked at, and we will be looking at some other ones throughout this lesson. Finally, looking at the line graph, and a line graph is best used to track changes over short and long periods of time. Again, we can use bar graphs for that as well. However, line graphs tend to generally be used for that as solely, even though we can use bar graphs for it. But it is important. Bar graphs, we showed the changes when it was a large, when there were large changes. So when there are small changes, line graphs are better. So if you're looking at something over time where there's the short or long period of time and the changes are small, a line graph is better. And in general, if you're looking at the change over time, you probably should use a line graph in general compared to a bar graph. Because necessarily the height of the bar graph isn't really what's important, it's how it changes from, say, year to year or day to day. So again, those were the different types of graphs that you can use or you can put data into and when they're best used for. So we're going to be going through and again looking at similar types or different types of each one. So we have our bar graph. So most popular global messenger apps as of October 2021 based on the monthly or the number of monthly active users in millions. So we have WhatsApp, Facebook Messenger, WeChat, QQ, Telegram, Snapchat, and then millions of users. So why is a bar graph a good graph to display this data? Well, because we're comparing different categories. We're looking at all the different messenger apps. So that's, again, if we go back to that chart that we just filled out, we are comparing different categories. And then how many people in total were being surveyed? Well, if we go through, we have 2,000 plus 1,300 plus 12,000 or 1,200 or 1,251 plus 591 plus 550 plus 538, which equals 6,230. However, we have to keep in mind that this is looking at users in millions. So this is actually 6,230 million. Because that's what the units are in. Why do you think someone would collect this information? So again, the answers may vary to this depending on what you think or what you want to argue, but you could be looking for maybe which app is most popular. Right? Maybe you're trying to do a survey to figure out which is most popular. Maybe you're looking to sell ad space or you're looking to invest money. Right? Or maybe you're looking to buy one of the apps, right? You saw recently the buyout of Twitter by Elon Musk, right? So maybe if you have tons of money and you want to buy a messaging app, you would look at, well, which is the most popular? Which ones do people use the most? Moving on to our double bar graph. So this is the distribution of Instagram users worldwide as of October 2020 or 2021 by age and gender. So again, why do you think they used a double bar graph for this data? Well, we're comparing two specific categories. Right? Male and female, or the two genders in this case. So we're looking at two specific categories over a certain characteristic, right, which is the age. So the key thing is we're comparing two specific categories. So in this one, we're looking at males and females and the number of users based on age for Instagram. Why do you think someone would collect this information? So again, the answers may vary, but it could be maybe who to market the ads for, or who to market ads towards, right? If you're trying to promote something, you see the age groups. So you might say, okay, if I have a product that is geared towards individuals from 18 to 34, I might post it on Instagram, or I might promote ads on there because I know most of them are using them, right? Or if I'm trying to sell ad space, again, I can know which ads I'm going to try to gear it towards. Right. Can you think of an issue with this graph? Now again, answers may vary depending on what you see. But looking at it, there's a couple things that you might consider to be off. One, the graph only goes up to 20%. So it only goes up to 20%, but if we look at it, right, all of these values are relatively small. Right? So we're going down, the highest is 17.9%. So 17.9% of the users are male between the ages of 18 and 24. So again, it's not a relatively high number, but based on what we're looking at, right, or based on the graph, it does appear to be a high number, or it looks high because of what the scale is. So maybe if they put the scale up to 100%, then we'd see that maybe it's not quite a lot of people actually. The other thing you might think of, if you look at the intervals, we have inconsistent intervals. Right? If we're looking at them, 13 to 17 is only 4 years. 18 to 24 is 6 years. 25 to 34 is 9 years. 35 to 44 is also 9 years, and they do seem to stay consistent from there on, but we have a different range at the beginning. So again, that could be an issue because it could be skewing our data. So again, just things to think about, things to look at. Moving on to histograms. So again, what is the graph displaying? So looking at this is looking at the batting average and the number of players on the Toronto Blue Jays in 2016 that fell within a certain range. So this is the number of the number of players number of players whose batting average fall in a certain range. So we see the ranges are basically the start and the end point of the bars. So what is the range of each bar? Well, looking at this, we can see that the value is 0.05, but because we're dealing with average, right, technically this is usually looks at percentage, right, your batting average, your batting percent, what is the percentage of the time that you're going to hit the bat. So you might say it ranges from 0.05, or you could say 5%. So why wouldn't this data be displayed using a bar graph? Well, first, you're looking at a range of values. So you're looking at a range of values. And the key thing here is that the range of values, or the values that we're looking at, aren't necessarily fixed. And what we mean by that is that not all the values are going to be the same. It's not like each value is a category. You're going to have 10 people or 8 people in this case that fall specifically on, say, 15% or 0.150 batting average. Because every value is probably going to be different, right? That's why we include ranges. So the ranges allow us to put any value between 0 and 0.05 in this category or in this bar. So we look at the frequency there. So again, that's kind of why we use a histogram instead of a bar graph. If it was a bar graph, chances are we would probably have just a height of 1 for every single individual value, because every single batter is going to have a different value or a different average. So not every player's average is the same. Moving on to look at the circle graphs. So again, here we're looking at Ontario COVID-19 cases and outcomes by vaccination status. So we're looking at kind of the population, or at least in terms of the data that we've gathered, and breaking it up, or looking at each proportion in terms of new cases, total hospitalizations, non-ICU, ICU cases, and the vaccination status for all ages. So again, what information can this graph tell us? And again, answers may vary, but generally speaking, it's showing us the percentage of each group that is, or the percentage of each group's and their vaccination status. In the different settings. So we're just basically seeing how the different statuses are dividing up these different cases, whether it's new cases, hospitalizations, and so on. So we're just seeing the breakdown of the overall percents, or of the proportions. Lastly, looking at line graphs. So what information are the line graphs telling us? Well, we can see the rates changing per year. So the rate of unemployment are changing from year to year, or from year to year. So again, it's the idea that we're seeing changes over time. So why might the data be represented this way? Again, your answers may vary, but because we talked about line graphs, we're seeing a change over time. And in some cases, they're relatively small changes. So relatively small changes overall. So that's why it might be better to use a line graph. And again, we talked about anytime we're showing a change over time, we probably want to use a line graph in general. So lastly, we're looking at two different graphs. And we want to ask the question, which graph displays the data better? So if we look at one, both of them are showing the same data. They're showing the percentage of people playing Minecraft from year to year to year to year. Now, which one do you think best displays the data? The data is the exact same in both of them. Right, we see the percentages. One, it looks like a very minimal change. The other one looks like it's a very drastic change. So again, your answers may vary. You might say the first one on the left shows the data better because it's showing that there's not much of a change, right? So something like this one, so there's not much of a change overall in terms of the percentage of people. The second one, you might say, well, the second one on the right, that one actually shows the data better because it is showing the actual values and showing the difference from year to year. So this one is zoomed in. We're actually showing the changes. But you might say, well, it's exaggerating the changes. It's making it look like the change is much larger than it is, when in reality, we're only going up by 0.2%. So again, you could argue either way for them, depending on what your argument is. You could say the first one is better displaying the data because it shows that there's not much of a change. Or you could say the second one is more accurate because it's actually showing what the change is from year to year. Yes, it's a small change, but there is still some change, and we can see it better from year to year in the second one. So again, your answers may vary, again, depending on what your argument is. But as long as you're arguing it or you're providing a strong justification for your answer, then usually that's okay. So again, the main thing in this lesson was looking at the different types of graphs, when we should use them or for what type of data we should use them, and then just analyzing or reading or going through and reading some of these graphs.